Well, welcome. In this video, we're going to be looking at the law of cosines. Now, up until this point, we've been working a lot with the trigonometric ratios in the previous videos. And one of the things that I've tried to emphasize in those videos is that the trigonometric ratios, the sine, the cosine, the tangent, they only apply to right triangles. Now, in reality, that's not always going to be the case. We will not always be working with right triangles. Well, we still have to have some way to be able to work out some information, to be able to find maybe the length of a missing side or to find the value of a missing angle. So we have to have something in our math toolbox, so to speak, that we can pull out to be able to use for those different situations. Well, one of those tools that we're going to use when we're not working with a right triangle is the law of cosines. Now, just like any other tool, there's going to be certain times that we're going to use it and certain times that we're not. And we need to know when to use that particular tool. Well, the tool that we're going to be learning about today with the law of cosines is only used when we're dealing with this side of a triangle. So a situation where we know all three sides of a triangle, but maybe we're trying to find the value of a missing angle. Or if we have a situation that's a side angle side scenario. And what that means is that if we know two sides of a triangle and the angle, we call that the included angle, the angle between those two sides, that's a situation that we would also use the law of cosines. Now, if we're not using one of those scenarios, side, 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 or side angle side, then chances are we're going to have to use a different method called the law of sines. We'll learn about that in a future video. But what is the law of cosines? Well, that's right up above here. Now, it looks like a lot, and it is a lot, but the more you practice it, you're going to see it's really not that complicated. It's basically what you're doing is, if we're trying to find the value of a missing side, we're going to take that side, the c, call it c squared, equals the other two sides of the triangle, the a squared and the b squared. We're going to add those together, a squared plus b squared, and subtract from that sum, double, so minus 2 times those two side lengths, the a and the b, times a cosine of the angle c. Now notice the angle that we're looking at is across from the side that we have isolated on the other side of the equal sign. That's important to recognize because sometimes our triangles aren't always going to be using sides or angles called, with A, B, and C. They're going to have different letters that we'll be working with. So you just need to recognize here that the side that's all by itself on the other side of the equal sign in the triangle is the side across from the angle measurement that we're going to know. So let's look at an example now that we're going to use the law of cosines.
Okay, so here it says, suppose that the distance of a laser telescope to the center of the throwing circle in a discus competition is 30.1 meters. From the telescope to the target is 51.02 meters, and the angle between the telescope's path to the target and to the center of the throwing angle is 95 degrees. Find the length of a throw from the circle to the target. Now here's something important to also note about a discus competition is that the distance that the discus has been thrown is measured from the edge of the throwing circle. And that throwing circle is going to have a diameter of 2.5 meters. So in the end, when we go to get our final answer, we're going to have to take and subtract from our total the radius of the circle. But we'll get to that in a little bit. So first off, if I look at this triangle here, I want to find this length here from the center of the circle to where the discus landed. So to do that, I'm going to have to use the law of cosines. So it's kind of convenient that they're using the letter C here, and this is angle C. But just recognize that the side that we're looking for is across from this angle that's 95 degrees. So when I go to set it up, I'm going to have c squared equals my other two sides, the 51.02 and the 30.1 squared. And we're going to subtract from that so 2 times these two values again, so minus 2 times the 30.1 times the 51.02 times the cosine of this angle. That angle is 95 degrees. So we're going to plug this all in our calculators all in one shot. So why don't you guys get out your calculators. And what we're going to do here is we are going to type in, like I said, we're going to type in this whole equation, the whole expression on the right side of the equal sign. So what we're going to put in is going to be the 30.1 squared plus 51.02 squared minus 2 times, you can write that using parentheses or type this in using parentheses or the times symbol. It'll be 30.1 times the 51.02 times the cosine of 95 degrees. So when we hit enter, we get 3,776.74. So we'll write that down in our notes. Now it's important that when you're doing these on your own, that you show your work exactly as I'm doing here. So don't just write down a final answer, because I know once you get the hang of the process here, it's real easy to know what to put in your calculator. But I need to see what, and your teacher needs to see, what it is that you're exactly doing to get this answer. So we want to make sure that we show our work. Now when we go back to when we go back to answering this, now we're not completely finished here, because I know that c squared is 3,776.74. I want to figure out what's our value for c. Well, in order to do that, I have to take the square root of both sides. Now technically that would mean that I'd have two solutions, a positive and a negative, but we're not going to have a negative length here, so we're just going to focus on the positive solution. And the way that we're going to do this on our calculators, because we want to make sure that we're precise here. So I'm going to do Control X squared to access my square root. But I don't want to just type this in or round this, because sometimes that could throw off my answer a little bit if I round to a digit that's too close to the decimal. So what I'm going to do to be more precise is I'm just going to hit Control negative. And when I do that, we see this ANS. That references the previous answer. So now I don't have to worry about typing in any numbers and making a mistake there when I type it in. I can just do Control negative and hit enter, and it takes the square root of that. You can see it changed here. And my answer now is 61.46. But remember, that represents the distance from the center of the circle to where the discus landed. But that's not what we want. We want to know what's the distance from the edge of the circle to where the discus landed. So remember that they say that the distance here, the diameter of this circle, is 2.5 meters. So that means the radius is going to be half of that, which will be 1.25 meters. So we're going to have to subtract from our distance here, the 61.46, the radius of the circle, which is 1.25, to get a total distance of 60.21 meters. So that represents how far that discus traveled from the edge of the circle to where it landed. Okay, I'm going to have you guys try this next example on your own, but I'm going to help you get it set up. It says the stars Sirius and Procyon are the first and seventh brightest stars, other than our sun, in the sky. One reason is that they are among the closest stars to the Earth. Sirius being 8.6 light years away and Procyon 11.4 light years away, the measure of the arc between them in the sky is about 12 degrees. Use this information to estimate how far Sirius and Procyon are from each other. Well, let's say this is our planet Earth. And let's say this is one of those stars and this is the other one. Well, the distance, we'll call this first one Sirius. The distance between Sirius and Earth is 8.6 light years away. And this one then will be Procyon, however you pronounce it. That's 11.4 light years away. And the angle between these two is a total of 12 degrees. We want to figure out what's the distance here between the two stars. That's what I want you guys to find. So why don't you take a minute and pause the video and work this out, and then hit play when you're ready to check to see if you have the correct answer. Okay, you should have gotten an answer of 3.48 light years, or you might have rounded it to 3.5 light years. But to get that, you should have just taken 8.6 squared plus the 11.4 squared. Subtract from that 2 times the 8.6 and 11.4 times the cosine of the angle, the 12 degrees. And when you do that, you get 12.1248. Take the square root of both sides, and that gives you the 3.48 light years. Well, what happens if we're not trying to find the length of a side? What happens if instead we're trying to find the measure of an angle? Now, this would be kind of complicated if we just tried to use the law of cosines the way it is, because law of cosines traditionally is set up to find the measure of a missing side. Well, we want to rewrite that to find the measure of a missing angle. And the angle that we're going to focus on is cosine, or is the value of c, cosine of angle c in our formula. So here's the original formula. C squared equals a squared plus b squared minus 2 times a and b times a cosine of c. And again, what I want to focus on is this piece. I want to get that by itself. So I want to get rid of all this other garbage on that side of the equal sign. So I'm going to start out by subtracting the a squared and b squared from both sides. Well, that's going to result in having c squared minus a squared minus b squared equals the opposite of 2ab times the cosine of angle c. Again, my goal is to get the cosine of c by itself. Now, to get rid of this negative 2ab, we are not going to add 2ab to both sides. That is a common mistake that I see people making. Again, we are multiplying negative 2 times a times b times the cosine of c. So in algebra, to get rid of something, we always do the opposite. So instead of multiplying, we are going to divide both sides by negative 2ab. So that gets the cosine of c by itself. And the result is going to be c squared minus a squared minus b squared, all divided by negative 2ab. Now, in reality, we are not always going to be working with these letters. So something that I want to point out is this side right here is the side across from angle C. So you want to make sure that you recognize that, because if we're working with a triangle that's not labeled with the sides A, B, or C, or angle C, you're going to want to know which side C is, because that's very important, because everything else is based on the other two sides, A and B. So if you get this messed up, that means the whole thing's going to be messed up. So make sure that you recognize that the side C is going to be across from the angle we're trying to find. So this formula is going to be a really handy formula to know. So let's look at an example where we're going to apply that. So here, this is triangle ABC, has side lengths of 5.3, 6, and 8. Find the measure of its largest angle. How would we know that? Well, in a triangle, if you're asked for the largest angle, that's going to be across from the longest side. So angle C is this angle that we're going to be looking for. Now, if instead they had asked for the smallest angle, well, you could probably guess that you're going to look at the smallest side, and the angle across from it would be the smallest angle. But they are asking for the biggest angle, so in this case here, it's angle C. So, using this formula, it's going to be the cosine of angle C equals the side across from it, which is 8 squared, minus A, which is, we'll use 6 and 5.3. Doesn't matter which one you have as your A and B. So it'll be minus 6 squared minus 5.3 squared. All of that divided by negative 2 times my value for A, which is 6, times my value of B, which is 5.3. Now I want to show you something on your calculators. Now if you're doing this with a scientific calculator, you're going to have to do this part in 3 pieces. You would first start by putting in the numerator, whatever that is. So you put that in your calculator and get your answer and write that down. And then you would do the denominator, type that in your calculator, write that down, and then you divide those two values to get whatever this answer would end up being on the right side of the equal sign. Now, if you have the TI Inspire, there's a really, really good button to make sure that you're aware of that'll help you out. And that's the Control Divide button. When you hit Control Divide, it creates this fraction bar. So now we can type everything in our numerator and everything in our denominator all in one piece and then hit Enter to get our answer. So we're going to put in here the 8 squared minus the 5.3 squared minus the 6 squared. Arrow down to get to the denominator, and then it's going to be a negative 2 times the 5.3 times the 6. And that's just like we have it in our notes. Hit Enter, you get 0.001415. Now, recall from the previous lesson, in the previous video, to find out our value for c, we're going to have to take the inverse cosine of both sides, because the only thing that undoes the cosine to get the c by itself is to take the inverse cosine of both sides. So we would get the inverse cosine of 0.001415. And just like we did before on our calculators, what we're going to do is I'm going to take the inverse cosine, but instead of typing anything in, I'm going to hit Control negative to get to my previous answer. So that way we can make sure we're being the most accurate. So we get 89.9 degrees. And that's your answer for angle C. Angle C would be 89.9 degrees. So now what I want you guys to do is I want you to do example 2b. Referring to example 2a, find the measure of the angle of middle measure in triangle ABC. Well, you guessed it, you're going to have to look for the side that's got the middle length, which would be 6, and you're looking for the angle across from it. So for this one, we're looking for angle B. So why don't you guys take the time now to work this one out. So pause this video and hit play when you're ready to check to see if you have the right answer. Well, how did you do? Let's look. You should have gotten 48.6 degrees as your answer for angle B. Now, if you didn't get that, let's check to see where your mistake might have been. So you start out by taking, since we're looking for angle B, we're going to start by using the 6 across from it as our C in our equation. So 6 squared. Then it's going to be minus the other two sides squared. So minus the 8 squared minus the 5.3 squared. And that's going to be divided by the negative 2 times the 8 times the 5.3. So if you notice, if you set it up like this, the 8, 5.3, the last two terms are right underneath each other. And then when you put that all in your calculator using that control divide button, you get 0.6614 as your answer. Take the inverse cosine of both sides to find the value of angle B. So the inverse cosine of 0.6614 is 48.6 degrees. Well, there you have it. That is the law of cosines. It's important to remember for the law of cosines when to use it. If we're using the three sides of a triangle and finding the measure of a missing angle, we're going to look at the law of cosines as we just did here. Otherwise, if we're looking at a side angle side situation, that's where we're going to use the traditional formatting of c squared equals a squared plus b squared minus 2ab times cosine of c. So with that, good luck now as you work on your assignment.